Today we will take a look on this big boy, the Snapmaker 2.0 A350ENT, which means the all-in-one version from the bigger Snapmaker with the Enclosure and the TMC silent stepper drivers. Let's crank it open. Welcome to the Snapmaker family. Oh, and some stickers. We have a guide for the machine, and also, because this is the bundle, we have also a guide for the enclosure. We will start with the machine and then after that work on the enclosure. Packed out everything from the big box, and now comes the small boxes. After filtering down the boxes, there are not so many, to be honest. We have this fancy toolbox, the clamps, finally a good goggle for laser, which is a proper OD6 Plus, 190 to 540 nanometer, CE certified, and also a CNC glasses, which is just against the splitters. Wow, okay, that is slick. I take my gloves on. The power supply. Here is the touch screen, the controller, the magnetic holder. Here are the adapters and brackets. All parts are so well polished and looks pretty cool.
And here is the rock-solid one-piece die-casted aluminum base plate.
Packed out everything. We just left with the base, the linear modules, the power supply, and these parts, so it's not that much. It should be a quick assembly. The toolbox has everything labeled. The hot end mills for the CNC. These are the feet for the base. After unpacking all the packaging, the most important tool is this one. We will use it a lot. We can just open it and choose one of the head what we need. Let's say this one. Then put it back and put this in place.
Following the steps in the prettiest manual I ever seen, the assembly is entertaining. This is one of my favorite part, getting know your machine and at the end feeling that you are also involved a little bit of the final result. For the cable management I use some cable tie mounts to hold the cables in place. And just like that we are ready with the base structure.
Let's start with the 3D printing module. The 3D printer head, the CNC and the laser.
The 3D printing head fixed with 4 screws onto the X-gantry. The filament spool holder is pretty simple design, which works well with the delivered filament, but it tends to be too short for brighter spools. So if you want to use one of those or over 1 kilogram filaments, then you need to find some alternative solution.
And here is the hot bed. A lot of magnets, the temperature sensor, and the well-connected cable.
The heated bed is fixed through 22 screws, which helps keep it flat when heated up, but at the same time it is really time consuming if you want to swap between the different features of the machine. I missed some positioning pins for the magnetic sheet, which also would help a quicker swap between prints. So now I just put it on and shift it into place, which required relatively low force to do so.
And the first start.
After turning on the power supply, the Snapmaker will recognize which toolhead is installed, and it shows some related safety instructions, and because we installed the 3D printer toolhead, it prompts you to make first a bed calibration. The instructions are informative and clear. With the help of this 0.1 mm thick plastic calibration sheet, we can set up the perfect distance between the nozzle and the print surface. By the way, this procedure needs to be repeated every time when you swap from another toolhead. And now comes the filament. We have to push it into the print head, and after the nozzle reaches the required temperature, the filament can be loaded. We can see here that Snapmaker made a quality check on the print head with some blue filament. And awesome! We have just finished, but then we got immediately some outdated linear module messages. But no problem, because the Snapmaker has a Wi-Fi connection, you do not need any USB stick or computer to upgrade the firmware. Just go to the settings, firmware and click update. It will download the most current firmware and install it for you. At the 3D printer settings we can turn on and off the auto leveling and also set up if you want to perform it before or after the bed heated. And also choose the sample points amount between 3×3 and 5×5. And now I show you the quickest way how to assemble the enclosure. The side panels are made of this special laser-safe orange colored acrylic to be able to see what's happening in there, but at the same time it also protects against dust, fumes and has a sound dampening effect also, which we will measure later. The enclosure has an exhaust fan, 2 door opening sensors and LED lights. The wiring for all of these can be hidden in the aluminum extrusions with the help of the enclosed plastic clips. And we have just arrived to the marriage, where we can connect the enclosure with the machine. There are 4 S-shaped aluminum parts which are fixing the machine position inside the enclosure through its rubber feet. This video was sponsored by PCBWay, where you can order your custom PCBs, and they also offer CNC machining, sheet metal, 3D printing and injection molding services. They also have a community page with interesting projects like 3D printing, Internet of Things, home automation, wearables and many more. Check out the links in the description. After our sponsor break, let's see what can we find in the controllers menu. After turning it on at the first time, with the enclosure connected, we got an outdated enclosure module message. But again, real simple, by clicking the update button, it will download the required files and update itself. So now we got an extra enclosure icon in the menu, where we can turn off and on the LED lights and the exhaust fan. Under settings we can choose to light up the enclosure automatically after turning on the machine. Under files you can see the local and USB stored files, and here you can edit and sort them. Then under control you can move the 3 axes plus the extruder stepper motor and control the nozzle and heated bed temperatures. By calibration you can calibrate the bed and set up the nozzle height. And under the settings you can set up your Wi-Fi connection, change the language, get information about your machine. By user preferences you can turn off the anonymous data sharing if you fear that Snapmaker will steal your data. And here you can check for firmware updates and read some info about the new features and improvements of your actual firmware. By 3D printing settings you can toggle the auto leveling and heated leveling features. And now it is time to finally print something. After launching the Snapmaker Luban software, I choose the 3D printing option, import an all-in-one 3D printer calibration model made by Gabo X3D, and after a quick repair, generating the G-code file with the default normal print setup, we can load the G-code to the workspace where you get a quick preview about the model. By connection, we can connect to the machine through Wi-Fi and we get a prompt window on the screen which need to be accepted, and after that we have connected. We can control from here the enclosure features also, like the LEDs, but we can even send G-code commands. For example, the M1010 S3P100 will turn on the LEDs on full brightness. With S4 we can control the exhaust fan. And here is an Easter egg. If you write a smaller number after the P, we can even dim the lights or slower the exhaust fan speed, which are not possible in any other way right now. From here we have two options: send it to the device or start the print on Luban. If we choose the start on Luban option, we will lose the power loss recovery feature, but more about that later. So I stopped the print process, resliced it with the fast print option to reduce the printing time from 10 hours to 4.5, and send the file to the device. On the touchscreen, however, we cannot do anything until the Wi-Fi connection is live, so first we have to disconnect from it. I quickly delete the 10 hours long version and I'm starting the print that we have just uploaded. By checking the first layer, I have realized that it is too close to the build platform. But after I set up the 0.05 mm Z offset, it looks much better. It took almost 5 hours to finish the print instead of the 4.5 hours prediction. The door opening mechanism prone to stuck sometimes, but with some practice you can open it much better as I did it here. The flexible print sheet should help us to take off the part just with bending it, but probably because of the too low first layer height I had, it tends to bond really hard to the surface, so I had to use the spatula to release it. Because I am much more familiar with the Prusa Slicer and it has a built-in Snapmaker profile, and also because it has much more features as the Luban, I sliced the same file with the same layer heights, infill density and first layer speed as the Luban had, and exported it to the USB stick. And then I plugged it into the most fancy USB connector I ever seen on a 3D printer and then started the print. One disadvantage of the default Prusa Slicer Snapmaker profile that it has no compatible thumbnail options right out of the box, but we can use a post-processing script if it is important. You can find the link for the script in the description. Notice that the Prusa Slicer estimated printing time is 3 hours and 42 minutes, whereas the Snapmaker predicts 2 hours and 26 minutes. The first layer was perfect in this case. The second layer printed much faster, and the printing job was done in 3 hours and 52 minutes. It took just 10 minutes longer as estimated by the Prusa Slicer. And now the print could be released much easier from the bed. By comparing the two prints from which the Luban sliced took 5 hours and the Prusa slice less than 4 hours, we can see the differences on the edges, on the bottom where the Z-hop provides a much cleaner result from the Prusa Slicer. The same is true for the top surface also, where the traveling movement left some visible lines. The seams are hidden much better by Prusa Slicer, which results a cleaner surface. By the overhangs we can give it a draw. Because of these points I use the Prusa Slicer from now on. And let's start immediately with a 3 days long print, which is the Black Panther mask. After the two main parts are bridged together, I had the feeling that it is now rock solid and nothing bad could happen. To spare some time and filament, I sliced this print without any supports. Because of the big print volume, we are able to print such masks in one piece. I have checked the print job regularly and it looked really promising. Until once... Layer shifting! Why? The already printed surface was so nice, but then I realized that the whole build platform is shifted, which is caused by the upcurling filament between the eyes and the nose part. It seems like the Snapmaker has no collision detection feature, however the built-in TMC stepper drivers would support that. By checking the power consumption, it took almost 7 kWh to reach that point. The peak power consumption was 335 watt, which is not bad from a 320 watts power supply. For the next attempt I used the black matte PLA Plus filament and also put some supports onto the critical parts. With this setup, the mask was printed successfully. After taking it off from the build platform and removing the supports, I could finally try it on and it fits perfectly. With sunglasses, it looks even better. I'm really happy with the result. To print some useful parts, I choose some extensions for the Snapmaker itself. The first one is a tool head holder with some organic supports. Crazy how well it works. There was some stringing, but the overall print quality was flawless. After installing the spare door slider plastic T-nuts to it, I have removed the strings with the help of a hairdryer and slide it into place, and now we also have a handy tool head holder for our machine. The next extension I tested was a poorly designed touchscreen holder. The most flathead screws also needed a little bit of filing to be able to slide it in place. I have changed it to another better design later. You can find a link in the description. Then I also tried to print some flexible TPU with the default Prusa Slicer configuration, but after the first layer, the 35 mm per second print speed tended to be too high and the filament jammed inside the extruder. But removing the Hilbert curve infill was fun though. As a second attempt, I went down with the speed to 15 mm per second and raised the nozzle temperature to 225 degrees Celsius. Like this, the part was printed, but it seems like the nozzle temperature was not high enough because there was a poor layer adhesion at the end. With higher temperatures, it could be a flawless print. Because I ran out of the TPU, I have printed this part from PLA again. And finally, I made some testing. One thing that I would ask from Snapmaker is to be able to override the slicer settings during the heat-up process. When I started the flexible print, I have realized that the heated bed temperature was set up to 60 degrees Celsius, which is not needed. So I tried to turn it down, but when I went back to the main screen, the 60 degrees Celsius was still present. My next attempt was to pause the print and then set up the new heated bed temperature, which first seems like working, but after I continued the printing process, it jumped back to 60 degrees Celsius again. So I end up to wait around 6 minutes until it's reached the 60 degrees Celsius, and after the printing started, I could finally turn it off. As a next step, I placed the thermometer into the nozzle, which was beforehand cleaned with a cold pooling technique, and compared the temperatures. They are practically the same, so no adjustment needed here. Then I measured the noise level from 1 meter distance with the enclosure open and closed state. We can see that from the mid 50 decibel it went down to the sub 50 decibel range. And now let's take a closer look on the heated bed. I set up 100 degrees Celsius as a target temperature and measured the time and also recorded with a thermocamera to check how uniform the heat distribution. It needs around 6 minutes to reach the 60 degrees Celsius, and around 16 minutes to reach 80 degrees Celsius. Officially that is the maximum temperature which is able to reach, but I was curious what is the reality, and it topped out at 88 degrees Celsius after 32 minutes heating time. The temperature distribution, however, looks really uniform. One very important feature by 3D printing is the filament runout recovery. So I also tested it, and as we can see, it recognized when the filament ran out and moved the printhead up. By clicking ready to load, the nozzle will heat up. If the filament not unloaded itself by pushing the unload button on the touchscreen, we need to remove the filament manually through this little service door. After the filament loaded, we can continue the print process. The nozzle will extrude some filament which we need to take off by hand, then it will move the nozzle to the exact position where it stopped, and then makes an unnecessary blob before it starts to move again. Why? If we are lucky, it is somewhere inside, but if not, we will definitely see this blob on the finished product. And finally, a power loss recovery test. By losing the power, the printer just stops where it is, not moving the printhead quickly away like the Prusa printers, which can be a problem if the printhead cools down and fusing with the printed part, because after we click resume, the printhead is raised immediately, which is in combination of a cool down heated bed, can pull up the whole printed object from the bed. Would be a better option to raise back up the temperature again, and just after that moving to the home position. The resume process is the same as by the filament runout recovery. After the temperatures reach the setup values, it extrudes some filament, moves to position, makes a blob, and continues.
So after this first episode of our Snapmaker review series, you got a feeling about this machine's 3D printing capabilities. In the following episodes we will take a look on the laser and the CNC modules also. The 10-watt laser tool head and the rotary module will be also tested, and we will take a look on the available extensions like the emergency stop button. If you are interested on other extensions, then write it into the comment section. For deals and promotion codes, check out the description section below, where we will update always with the actual ones. But now let's see the pros and the cons of this 3D printer setup. Pros: the safety functions like filament runout and power loss recovery. Wi-Fi connection to transfer files, control and make firmware upgrades with ease. Fabulous build quality. Those aluminum parts speak for themselves. Good quality tools and accessories are enclosed. Silent operation thanks for the new power supply and TMC stepper motor driver upgrades. User-friendly and clean touchscreen controller surface. Compatibility for third-party slicer software and filaments. In combination with the enclosure, even lower noise level, built-in LED lights for better visibility and exhaust fan against the fumes. The cons, software related, missing collision detection, setting override issue, no touchscreen functionality when printing over Wi-Fi, blob by resuming the print. Luban built-in slicer is very basic and predicts the printing time fastly. Hardware related, no positioning pins for the magnetic print sheet. Filament holder is limited for smaller spools and narrower spools. And flexible filaments can be just printed with very slow speed. About the price, the smaller F250 only 3D printer version starts from 699 euros. With 100 euros extra you can get the bigger one, and if you want to extend its capabilities later, thanks to its highly modular design, you can do it with the separately also available accessories. But if you decide to jump right into the bigger all-in-one bundle with the enclosure, you can get it for 1,599 euros now. All prices at the time of the video release. Thanks for Snapmaker for providing us their machines for these reviews. I hope this video was useful for you, and see you with the next one.